Okay, we're going to complete this paragraph proof, and they've given us that angle A and angle D are right angles. Great, and side AB is congruent to side DE, and we need to prove that the two triangles are congruent. So let's look at the proof and filling in the values. It says it is given that angle A and angle D are right angles. So blank by the definition of right angles. Well, we can say for A, oops, sorry about that. We can say for A that angle A is congruent to angle D by the definition of right angles. All right angles are congruent, so we know that since they're both right angles, those are congruent. We need to state that. That seems like it's so obvious that we don't need to state it, but it's implied, but we need to make explicit what is just implicit. We can't just assume everybody knows it. We need to actually state it, okay? So we state that angle A is congruent to angle D by the definition of right angles. And now for B, blank because of the reflexive property of congruence. And what we want to do is we want to say side BE is congruent to, and just because I want to maintain a sense of consistency here, what we are talking about when we write congruence, we can say that it's reflexively congruent to itself, so BE is congruent to BE, and that's true. But if we want to name the matching vertices, and hopefully you can imagine that if we took this top triangle and we were able to somehow separate it and rotate it 180 degrees, then actually this vertex E would land up here on B. You can see it's at the top of the short side, the other side of the short side from the right angle, just like B is here. So E corresponds with B, and that on the top triangle, that pointy vertex here, B, will rotate around and match with the pointy vertex E here. So actually, if we were going to correctly write the congruence statement of this side, we would say side BE is congruent to side EB. We're doing that because we want to be able to align the vertices, and it's a fact that B on one triangle, the vertex on one triangle corresponds with E on the other in terms of position. So B corresponds with E, E corresponds with B. They will kind of swap places if you rotate them 180 degrees. So we're going to write it like that and make sure that when we're naming parts, that we're naming all of the parts, each letter congruent to what it's congruent to on the other one. So for C, it is also given that, well, what's also given? Well, they told us that the angles are right angles. We determined that that middle line was reflexively congruent to itself, and it is also given that, so it's also given that side AB is congruent to side DE. And you can see they're doing the same thing here. They're going from the right angle to B, and they're going from this right angle to E. So AB, DE, they're getting it right as well, the way that we want to. And what's the last thing that we need to put? Okay, so triangle ABE is congruent to triangle DEB by what? What's the rule? Well, we know that we've got right angles, and we've got the hypotenuse reflexively congruent to itself. And we have one of the legs of the right triangle, so by hypotenuse leg is fine. You can also put hypotenuse leg theorem, and we've shown all the parts we need to show, so we're done.